Okay, so prereq section 3, and we are in trig still. So let's take a look here at our prerequisite section. What do we need to know before we dive into trig here? We're talking about integer exponents. So there's me with my English mastiff. Hooray! We're dancing. She's much taller now. That's surprisingly enough when she was a puppy.
What? I didn't have any corn.
Exponent notation. A to the n. Okay, is what we're talking about here. A to the n. We'd write that as a times a times a times a times a, and because it's to the nth power, I have no idea how many times we would write that. That's the point. So that's why it keeps going dot dot dot. So an example of that would be 3 to the third power. I'd write it as 3 times 3 times 3. And 3 times 3 times 3 is 27.
The Human Torch was denied a bank loan.
So 5 to the fourth power, I'd write as 5 times 5 times 5 times 5. Right? I'd write 5 4 times. And 5 times 5 times 5 times 5 is 625. Thank you. 1/2 to the fifth power, I'd rewrite as 1/2 times 1/2 times 1/2 times 1/2 times 1/2. So when I go to multiply those, I multiply the tops. 1 times 1 times 1 times 1 times 1, which is 1. 2 times 2 times 2 times 2 times 2 on the bottom, which is 32. Negative 3 to the third, which means I take that negative 3 times. Negative 3 times negative 3 times negative 3. So negative 3 times negative 3 times negative 3 is negative 27. Because these two, when you multiply them, give you a positive 9, and 9 times negative 3 is negative 27. Negative 1/3 to the fourth is like saying negative 1/3 times negative 1/3 times negative 1/3 times negative 1/3, 4 times. So when we multiply those, I'll just take the negative through to start. Well, a negative times a negative is a positive. A negative times a negative is a positive. So basically what I'm telling you is our final answer is going to be positive. So we can just forget about those negatives because these two will form together to be a positive number, and these two will form together to be a positive. And a positive times a positive is positive. So 1 times 1 times 1 times 1 is 1. 3 times 3 times 3 times 3 is 81.
I drank a lava lamp. It wasn't lava.
So 0 and negative exponents now. Anything to the 0, anything at all to the 0 is 1. Anything to the 0 is 1. So 3 to the 0, 1. So a to the negative n. Whenever you have something to a negative exponent basically means you want to flip it. So since this is in the numerator, hypothetically, this is up top, I'm going to move it to the denominator. So I move that negative down. So notice how the only thing that changed here was it's no longer negative. See how that's no longer negative? It's just on the bottom. It's still a to the n, but it's on the bottom. So 3 to the negative 4, I move all that down to the denominator is what I'm saying. So it would be 1 over 3 to the fourth power. So laws of exponents now. And once again, the reason why I'm kind of going fast with this stuff is if you're watching this video and you're in Algebra 2 or you're in Algebra 1, the videos I have are more directed towards you and they move a little slower. This is for trig, and this is stuff that you guys should already know. That's why I'm moving faster through this material, so please keep that in mind. Anyone who is looking at this is supposed to be a little quicker because it's supposed to be a refresher. That's why it's a prerequisite. You should already know this stuff. But anyway, continuing on here, a to the m times a to the m, n, a to the m times a to the n. Since the bases are the same, if you remember your rule from Algebra 2, that means you add the exponents together. So 2 to the fourth times 2 to the eighth means you add the exponents. So you get 2 to the 4 plus 8, and 2 to the 4 plus 8 is 2 to the 12th. So 2, you got a to the m to the n. When you have parentheses, these parentheses right here mean you're going to multiply those exponents. So this is really like saying a to the m times n. So if I was to give you an example of 3 to the 8th to the 4th, What that means is you take that 8 and 4 and you multiply them together to get 3 to the 8 times 4, which is 3 to the 32. All this in parentheses, a times b to the n. Well, keep this in mind. This exponent, there is an exponent here. This exponent here is like saying a 1. This exponent here is like saying a 1. So really I'm taking that n and I'm multiplying it through to both. N times that 1 above there is n. N times that 1 above there is n. So really this is a to the n, b to the n. You're just multiplying that through to the exponent on top. So in this problem, this 2 has an exponent. It's 2 to the first power. So I'm going to take that 3. 3 times 1 is 3. This x has an exponent. We just don't write it. That's a 1. So that becomes 1 times 3, which is 3. This is where people normally get this wrong. Normally people just take this 3 through to the x, but you got to remember to take it through to the numbers as well. Every single variable gets that exponent, and every single number as well also gets that exponent. So 2 to the third is 8, so really you get 8x cubed. So remember, this is a tricky one here. Remember, you got to take that 3 through to the numbers and the x's as well. Okay, so laws of exponents here. A over b to the n, this is just like the multiplication one. That's like saying a to the first power and b to the first power, so you need to take that n through to both items. So you get a to the n over b to the n. So right here, 2/3 to the 4th, you take that 4 through to both the top and the bottom. So you get 2 to the 4th over 3 to the 4th. Because remember, it's like saying 2 to the 1st. 1 times 4 is 4. It's like saying 3 to the 1st. 1 times 4 is 4. And you're getting 16 over 81. A to the m over a to the n. Well, when you have a fraction, just like in multiplication, when we had a to the m times a to the n, you added them. Well, now this is division. So because it's division with exponents, you now subtract a to the m minus n and a to the m minus n. So 2 to the 4th over 2 squared, you subtract the exponents. So 4 minus 2 is 2, and 2 squared is 4. So another example here, 2 to the 3rd and 2 to the 5th. You still subtract, even though the bottom's bigger, still subtract. 2 to the 3 minus 5. Well, what's 3 minus 5? Negative 2, right? And what rule do we just go over with negatives? Whenever you have a negative in the exponent, you got to move that, right? So since this is on the top, let's move it to the bottom. So we actually got 1 over 2 squared, which happens to be 1/4. Another little rule I like to tell people, whenever you have fractions, wherever the exponent is bigger is where your answer is going to go. Look up here. Which exponent is bigger? This 4, right? So notice how when we subtract, the answer went on top, right? This didn't move to the bottom like down here. It stayed on top. Over here in this problem, which one's bigger? The 5. And notice how our answer ended up on the bottom as well. So wherever the exponent is bigger is where your final answer is going to end up. So you subtract and you can get the answer. So my point is 4 minus 2, the 4 is bigger, goes on top. So it's 2 squared. 3 minus 5, you got a negative 2, so you know the answer of 2 squared has to go on the bottom.
This for friends and
Alrighty, so when we come back, we are going to dive into some more of these intense examples. We just went over the properties. We'll come right in and plow out some examples. So we will be back in a little bit.